Today in geometry, we're going to look at section 2.3, day 2, the laws of logic. So let's review a little bit. Okay, so yesterday we talked about the different types of reasoning. So recall what type of reasoning is based on observations or patterns and that may be incorrect. This, remember, is inductive. Change that font size. So inductive reasoning is based on observations or patterns and may be incorrect. Therefore, we could say that deductive reasoning is based on fact, law, rules, definitions, etc., and it should be correct if all the rules are followed. So we're going to identify the following as inductive or deductive. So number 1, Ms. Haskin has assigned homework every Friday. Today is Friday. Ms. Haskin will assign homework today. Okay, so this is an example of inductive because it is a pattern, right? It's not necessarily going to hold true. Not every single Friday are you guaranteed to get homework. Number 2, the school handbook rules state that all students must wear an ID to attend privilege time. You forgot your ID today, so you tell your best friend you won't be able to go to privilege time. This is deductive because this is based on rules. All right, so today we're going to look at laws of logic. We can abbreviate that as LOLs. These are rules which help us make more logical conclusions. They use deductive reasoning because we are given rules to follow to make our conclusions. We have the first type, which is called the law of detachment. This can be abbreviated as LOD. This one says, if P, then Q. So given a specific P situation, then specific Q conclusion is true. An example of LOD, the rule, if an angle measures more than 90 degrees, then it is not acute. Given angle J equals 120 degrees, then our conclusion is that angle J is not acute. Okay, so again, the rule was if an angle measures more than 90, then it is not acute. We are given the angle J is 120 degrees, so then we can conclude the angle J is not acute. Then we have what's called the law of contrapositive. We can abbreviate this as LOC. Remember, the contrapositive is where we have swapped places with the hypothesis and conclusion and negated them, put the word not in. So this one says, if not Q, then not P. If the conclusion is false, then the hypothesis must also be false. An example of LOC, the rule. If you order an apple pie, then it is served with ice cream. Given, Matt did not receive any ice cream. So what can we conclude? Matt did not order apple pie. Remember that when given a true original condition, only the contrapositive has to be true. The converse and inverse are often false in those. Okay? Right. So, trying to reason by using a false converse or a false inverse can lead us to make conclusions when we really should not. We call these fallacies. We have different types of fallacies. The first one is the fallacy of the converse, and that is abbreviated FOC. The rule, if you drink too much caffeine, then you will be hyper. Given, Bart is hyper. Conclusion, we really cannot make a conclusion, okay, because he could be hyper because he ate 10 candy bars. Okay, so he could be hyper because he ate 10 candy bars. Right? Lots of reasons that he could be hyper, not just because he drank too much caffeine. Then we have what's called the fallacy of inverse. We abbreviate that as FOI. The rule, if you drink too much caffeine, then you will be hyper. Given, Sammy did not drink any caffeine this morning. Okay? Again, I cannot have any kind of a conclusion here that would be true without a doubt because Sammy could be hyper without drinking coffee. So Sammy could be hyper without drinking caffeine. So again, maybe Sammy's hyper because he ate 10 candy bars. The only time you would be able to use the converse and inverse to make conclusions would be if your original statement was true in all four forms, like in the case of a definition. All right, so let's look at some examples that we might see in our homework. A, we're going to give the conclusion or write none if there's not one. We're going to give the law that we used, either the law of detachment or the law of contrapositive. Or if no conclusion was possible, we're going to give the appropriate fallacy, the fallacy of the converse or the fallacy of the inverse. For any statements with no conclusion, we're going to provide a counterexample. Okay, so they give me the rule. If you like fudge, then you eat sweets. What I often think is very helpful here is if we just come over here and go ahead and list our original, our converse, our inverse, and our contrapositive. Okay, so my original. So the rule says if you like fudge, so if fudge, then sweets. And this is true. Okay, if you like fudge, then you like sweets. Then you eat sweets. That's true. So then my converse is to switch those. So if you like sweets, then you like fudge. Well, that doesn't have to be true, so that would be false. And the inverse, so I negate the original. So if you don't like fudge, so no fudge, then you don't like sweets. Again, that could be false. And then finally, my contrapositive. So I switch the, I negate the converse. So I would say no sweets. So no sweets, then no fudge. That is going to be true because if I don't like sweets, I'm not going to like fudge. Okay, that table is going to help us with if we can reach a conclusion. So it says Delphi eats sweets. So I come over here, okay, sweets was first in my converse. And we said sweets and fudge is false, okay? So just because you like fudge, okay, it says, sorry, our rule starts out, if you like fudge, then you eat sweets. So then it would tell us Delphi eats sweets, okay? Our conclusion would be none. The fallacy is FOC, fallacy of the converse. And the reason, okay, may not like fudge. May not like fudge. Let's see if I can. Okay. So the next one, so if you like fudge, then you eat sweets. So then Josie loves fudge, okay? So up here, okay, fudge was the original, fudge to sweets is true. So then this is going to be, okay, we can make a conclusion based off of this, okay? So our conclusion, if Josie loves fudge, then Josie eats sweets. Okay? And then we have to identify what rule that was, okay? This was from the original statement that we started out with. So this is from the LOD, the law of detachment. All right, so now, if you like fudge, then you eat sweets. So number 3, Travis won't eat any sweets. So come down here, no sweets means no fudge, which is true. So we can reach a conclusion. Our conclusion will be Travis won't eat fudge. Now we have to list what rule did we use. We were looking at the contrapositive, so that is the LOC, the law of contrapositive. Again, the rule, if you like fudge, then you eat sweets. Number 4, Rory doesn't like fudge. So over here, no fudge, that was my inverse, and no sweets. Okay, so if Rory doesn't like fudge, then it says, then Rory doesn't eat sweets. Well, that's not true, because maybe it's just fudge he doesn't like. So my conclusion is none. My law of fallacy, this was the inverse that we looked at, so this is the FOI. And again, you might like other sweets besides fudge. Okay. A little bit. Okay. All right, so then we have to talk about what's called the law of syllogism. SYLLOGIS. Abbreviated as LOS, and this is AKA, which means also known as the chain rule. All right, so this says, if A, then B, if B, then C, if C, then D. So the conclusion, if the very first thing happens, if A, then the very last thing will happen, then D. All right, so let's look at some law of syllogisms examples. So examples of LOS. If you are texting and driving, then you are a distracted driver. If you are a distracted driver, then you are not completely aware of what is going on around you. If you're not aware of what's going on around you, then you may be in an accident. If you're in an accident, then you could hurt yourself or someone else. So see how the first if, okay, leads to a then. What was after that then becomes my next if. And then we have a then, what's after that next then becomes my next if, and so on and so on. So then I can say my conclusion if the very first thing that happened, let me look up here. So if you are texting and driving, then the very last thing could happen, which was you could hurt someone, you could hurt yourself or someone else. Okay, so now let's look at another one. Rule 2. If you wear school colors, then you have school spirit. If you have school spirit, then the team feels more supported. If the team feels more supported, the team will play harder. Okay, so the conclusion, if you wear school colors, then the team will play harder. All right, this is probably a very popular one that you will already know. Number 3, if an old lady swallowed a bat, then she swallowed an owl. If she swallowed an owl, then she swallowed a cat. If she swallowed a cat, then she swallowed a ghost. If she swallowed a ghost, then she swallowed a goblin. If she swallowed a goblin, then she swallowed some bones. If she swallowed some bones, then she swallowed a wizard. If she swallowed a wizard, then she yelled trick or treat. So that's from the Old Lady Swallowed a Bat book by Lucille Calandro. The conclusion is, if an old lady swallowed a bat, then she yelled a trick or treat. Trick or treat. So all of the old lady books are examples of law syllogisms. Also, the If You Give a Mouse a Cookie books, those are examples of LOS. Okay, and then there's also law of syllogism in marketing. These are direct TV commercials. In class, we will look at some that are school appropriate. Sorry, no Charlie Sheen allowed in school. But these are examples of law of syllogism. Hope you enjoyed it.